let me solve one more problem. Please subscribe to my channel and try to watch the videos online. Let me first state the problem. The problem is, let p of x interpolate f of x at nodal points x0 to xn. We want to show that p of x is equal to w of x times sigma k equal to 0 to n f at xk over x minus xk times w prime at xk, where w of x is equal to pi I from 0 to n x minus xi. In fact, it's a polynomial of degree n plus 1. Okay? Now, let me try to solve the problem. The solution is not very difficult, and just we have to compute w prime of x and then put instead of x xk, and then put in the summation and expand the summation. It's the trick is this. Okay, first we compute w prime of x, then put x equal to xk. Okay, it is the problem. We know that w of x is equal to x minus x0 times x minus x1 to x minus xn. Okay, let me compute w prime of x for just 3 parentheses, and then in fact I can conclude something very similar, because the computation of wx for n plus 1 terms is not in fact very it's simple, but it's very in fact full of computation, and it's not good. So let me consider wx equal to x minus x0 times x minus x1 times x minus x2. Okay, and let me compute w prime of x. Okay, it's easy, just we have to compute the derivative of these 3 parentheses that multiplied to each other. It will be, the first derivative is 1 times the second one, x minus x1 x minus x2 plus x minus x0 times x minus x1 times x minus x2 prime, right? And then we compute these, in fact, derivative. We will get x minus x1 times x minus x2 plus x minus x0, and here I will have x minus x2, okay, times plus x minus x1. If I multiply, I will get x minus x1 times x minus x2 plus x minus x0 times x minus x1 plus x minus x0 times x minus x2. Okay, if I write in the sigma form, it will be sigma j equal to 0 to 2, product I equal to 0 to 2, I is not equal to j, x minus xi. This exactly is equal to this one. If you expand, you will get something like this. In general form, we can conclude that f w prime of x should be sigma j equal to 0 to n product I from 0 to n I not equal to j x minus xi. There is no difference in the form of the function. Just the upper bound will change and will change from 2 to n. Okay, now put instead of x equal to xk. So I will compute w prime xk. It's equal to sigma j from 0 to n product I from 0 to n I not equal to j xk minus xi. Okay, and we know that all the terms of this sigma will be equal to 0 because in some place xk minus xk will happen, except in that place that j is equal to k. If j be equal to k, this will be equal to some product I from 0 to n I not equal to k xk minus xi. Let me note something. Other terms will be 0. You can check it. Now, you consider the right hand side of the desired result. Now, consider the right hand side of equation number 1. Let me call it equation number 1, right hand side. Okay, so I will have w of x sum k equal to 0 to n f at xk over x minus xk times w prime xk. Right? This is equal to, let me put instead of wx product I from 0 to n x minus xi. Okay? And multiply it by k equal to 0 to n f at xk over x minus xk. I rewrite, and instead of w prime of x, let me put this one. Pi I from 0 to n I not equal to k xk minus xi. Right? Something like this. Now, if you look at this term in the out of the sigma, there is no k here, so I can move this term, this product, inside the sigma. So it will be sum k from 0 to n pi I from 0 to n x minus xi times f at xk over x minus xk times I from 0 to n xk minus xi, and I not equal to k. Okay? Now, if you, in the nominator, you move x minus xk from this product out and cancel with the denominator, we will get this is equal to sigma k from 0 to n pi x minus xi over xk minus xi for I equal to 0 to n I not equal to k, okay, at f of xk. And if you remember the definition of the Lagrange interpolating formula, this is exactly the Lagrange interpolating formula which was P of x. And this completes the proof. It's over. Very easy and very fast. It could be proof. So please subscribe to my channel and wait for the more problems in the very close future. Thank you.